okay, I got this little window comparator I built, and you know, it in of itself isn't all that interesting. You know, this is a circuit board, and you know, here's the schematic here. So, but I made it kind of versatile. You know, got it so you can tie the outputs together if you want, because it's like a dual window comparator. And right now I got the inputs tied together, so you can actually have two different signal levels. I got the outputs separated. You know, you usually wouldn't need that, but the inputs, you know, yeah, you might need to do, you know, two separate, you know, levels on it. And let's see. But as you can see, you know the inputs don't have any kind of like load resistance or anything like that. So it's really strictly DC comparator out of the box. And you can see I've got it connected to a couple of LEDs, you know, and that's sort of the current shape of the input signal I'm applying to it. You know, it's a triangle wave, but I've got like but I went ahead and so you know, because again, the analog discovery only has like a, you know, it only has like a, you know, DC wise, only like a 5 volt signal range. So I was wanting to get more amplitude out of it. So you know, you can do double that, you know, AC, but you know, this is a DC only circuit, so you know, and I'm running it at like 9 volts. Right now, I could go to 12, you know, which is what it was designed for. But at any rate, I've got all this nonsense rigged up because I've got a, you know, little film capacitor here. It's about 2 microfarad, I think, um, and I've made a voltage divider, um, you know, to put across the inputs. So basically, you know, between um, VCC and ground, you know, I've got the midpoint tied to the input, so that's giving us a bias signal on that. So it's a 4.5 volt bias signal that our input signal, you know, which this is our input right here, is coming out of the analog discovery. Our input signal is coming out of the analog discovery, and you know, going into this capacitor, which then is hooked to this voltage divider that I have rigged up between the positive and negative supply rails. Um, so that's given us a, you know, a reference. So it's making that signal, you know, ride that, um, you know, that 4.5 volt signal. And you can't do it with just one resistor, you know, because obviously that'll pull it down to ground and it'll make the signal right on top of ground. But at least if I do that, you can see the other LED pop on. Although right now it's kind of fast, but let me. So, you know, I can't take this down to as low of a frequency because originally I had this large electrolytic here, which is like 1,000 microfarads. But I was trying to adjust the DC level, and see, there's what it does to the waveform. It's all already clipped, you know, because I got it turned up to full voltage. So the device is actually, you know, clipping it, putting that resistor on it makes it worse than just having no resistor on it. But you know, I take those levels down, and it's still going to ride on the lower DC. So, but at any rate, you know, it's hard to get the frequency down because this capacitor is relatively large. So the signal starts really diminishing, you know, as I lower the frequency because it's making a filter, because those two resistors are like 10K each. So, you know, but it's making a frequency, I mean, a filter. So, you know, an RC filter. Um, so, anyway, you know, but yeah, when I had this capacitor in there, I was trying to adjust the DC level down, but I turned the signal source down to 0. Well, that was actually causing the capacitor to go in to reverse conduction, because I had the positive side on the signal generator like you'd normally have it, and the negative side attached to the board. But yeah, that was causing the capacitor to go reverse bias and therefore act like kind of like a short, so I couldn't get the voltage higher than like 3.5 volts with the divider in there. So anyway, but yeah, that's what it looks like at lower frequencies. So you can see, that we're getting, I've got it reduced down to like 5 hertz or something. So again, it's not a pretty waveform, with this capacitor, and it was like perfect with this. When I was actually generating a waveform, I could generate, down to pretty low frequencies, even, with just that alone and no voltage divider. So, but it would always, there was always a negative diode voltage drop across it. So that means that, it was using the input protection diodes, it was riding on top of that negative voltage, but you would see it dip below that. I guess I could actually pull this loose and show you what I'm talking about. See, that's what it looks like, without the voltage divider at all. It's clipping, the lower half. That's the protection diodes switching in, but it's like minus 0.6 volts or so is what it's reading out. Yeah, minus 510 millivolts. So it's definitely using the protection diodes of the chip to clip it. But you do have a good signal. Even with this capacitor, apparently you do have a good signal, because we've gotten rid of one of the big filter components, because the impedance of the chips there, the inputs are probably going to be relatively high. I don't think on these 339 comparators they're as high as as like an op amp typically is, but still it's probably going to be at least like 50 or 60K, I would think. So that's pushing that filter frequency down, because it's such a large resistance. That's what you want, a large number in the denominator of that filter formula, 1 over 2 pi RC. The bigger the denominator, the lower the frequency. So that input impedance pushes it up, so it's no longer acting like the badass filter it was with 2 10K resistors effectively in parallel, meaning 5K. So that was a lot smaller, and yeah, but this works a lot better. So I can, throw square waves at it, sine waves at it, and even noise, and you can see this thing really go goofy with the noise signal. So, but at any rate, it's an interesting little window comparator, and like I said, I have a couple of different pots. These two adjust one channel, where they're multi-turn, so you can do it precisely, whereas these are just the regular single-turn pots. But again, this would allow you to have in either 2 independent comparators, window comparators, or to combine them like I did here, and because I have that little jumper right there, and that's what makes them act like a single input, to both comparator sets. So so you could have like 2 totally different windows set, like a yellow zone, which is broader, and so you're getting close, and then a green zone, which is much narrower, right in the middle, right, that lights one LED and the other, as you get closer. You could do things like that, or have them in 2 totally different bands. So because one of these is actually really low, and one of them is actually set kind of high. So you get different behavior out of it depending on like with a triangle wave. You get like I got now. You got different behavior. It's hard to see when it's flashing this fast, but at any rate, it's just a pretty cool little little thing. It could come in useful. Again, it's something I built years ago. I hadn't tested before today. So anyway, cheers.